Okay, calculating demand elasticity. Actually, I really don't want to do a lot of calculations. Calculations, as far as I'm concerned, usually obscure the economics. Usually when you get to calculate a lot of things, you get buried in the numbers and you forget what you're doing it, why you're doing it. So let's try a number of things over here. So this is a demand curve, and let's try a couple of elasticities, and let's see where the elasticity is high and where the elasticity is low, and see somehow graphically, if we could, what the elasticity means. So we're over here, and of course I'm just improvising. I'm not sure. Well, there is something like this S, T, and U on page 90, but what we usually do for elasticity is draw a curve which is tangent. You know what's tangent, right? Tangent means it just touches it without actually crossing it. So it passes through it, it touches it, but it doesn't cross. So write on this, so T, S, U, and let's say that the price changes a little. So the price from here the price changes a little, and when the price changes a little, you see that quantity changes fairly much. All right? So in general, when it's relatively flat, the elasticity is relatively high. Of course, not always, because if it's very close to the zero, to the horizontal, again, this percentage here is, again, relatively large. So what happens over here? Over here, you may as well get unit elasticity. Unit elasticity. In other words, you raise a little bit the price, and the quantity will change, and will change more or less the same. All right, so this distance and this distance is the same. So this distance and this distance, percentage-wise, will be more or less the same. Of course, this is just a rough picture. And on the rough picture, what you get here is that this triangle here will represent unit elasticity. Now, it's also tricky high up what happens. It's also tricky high up what happens, but usually what happens is a little bit of a change in the, here is, let's see, quantity, and here is price. A little bit of change in the quantity usually results in a fairly large change in the price. All right? So a little change in let's say, a little change in quantity results in a lot of change in the price. So here, this means it's inelastic. Well, is the textbook saying a little bit the opposite? Remember? What the textbook is saying? When we're close up there, it's fairly elastic. When we're close down there, it's fairly inelastic. Remember? So here is the next trick. Here is the next trick. Let me show you what's the next trick. This rule doesn't work well because you may have a demand curve which will go relatively far away, and elasticities here will be of one type, but you may get a curve which is very much like this. You see now what happens when the curve is very close, when the curve is very close to one of the axes, this or this. Here, a little bit of a change in a price actually results in a large percentage change. All right? Here, a little bit of a change in the price results in a low percentage change. So, let's take this section over here. All right? From here to here. You see, this percentage-wise is relatively small. But take the same difference from here to here, and from here to here, the distance is in absolute terms the same, but the way I've drawn it, it looks like the price actually increased double or triple. If the original price is here and the new price is here, this is a change of 100 or 150%. You see, where the change, the way I've drawn it here is maybe 5, maybe 10%. All right? So, what I'm explaining now is that you may have one and the same distance, but if the curve is very close, you have very high sensitivities very nearby the axis. If the curve is far away, the sensitivities are much lower. So we can't just generalize that, oh, if it's here, it's fairly elastic, if it's here, it's fairly inelastic, and vice versa. All right? So that's what I'm trying to illustrate is it's a little bit trickier than that. So it's not only if it's low or high, in other words, down low on the demand curve or high up in the demand curve, but also how close is the demand curve overall to the two axes. The more it is close to the axis, the higher will be the percentage. So this one is effectively 100%. Well, guess what? From here all the way to here. So this little change in price is 100% in terms of price. But the quantity here is a lot less. The quantity here, the way I've done it, this is a 20% change in quantity, maybe 25% change in quantity. All right? And this is 100% change in price. So in this area, from here all the way to here, is this elastic or inelastic? You double the price, but the quantity falls a little.
So it's inelastic.
Inelastic. Alright, you get the point now? On the other hand, if it's over here, the story is different. If it's on this curve, so this is the red curve X, demand for a person X, this is going to be different demand. You take this one here, you take the same distance, now we draw this over here, and over here it's unit elastic, roughly. This we could think of 10% increase in price, right? And this is roughly 10% in quantity. It is roughly unit elastic, all right? Again, I'm just trying to provide, okay, we don't need all the mathematical computations and everything else, but you have to have a feeling depending on how close or how far it is. Of course, when you're in business, you will have to understand your particular demand curve. In other words, for each particular product or service or group of products or group of services, you will have specific demand curves. For 1,000 products, you will have 1,000 different demand curves and 1,000 different elasticities. But the point that I'm making now is that for one product, you will have different elasticities along the demand curve too. Now, you can compute an elasticity at one particular point. and to compute what's called a point elasticity. For a point elasticity, you have to take a tiny little change in the price and a tiny little change in the quantity. In other words, a very small move along the demand curve to compute the point elasticity. Okay? So, you compute it from point X to point Y, and I make them super tiny because I want the distance between X and Y to be small. In mathematics, we call it infinitesimal. Infinitely small, alright? So, that's how you compute the point elasticity. Well, you use in mathematics derivatives and all the tools of calculus. In more elementary math, you can actually compute what the elasticity for a whole range or a segment. So this becomes a range or a segment, and I think they use the term arc elasticity because we're computing it actually over the arc. In other words, it is not the segment as in a straight line, but it is the arc because we move along the demand curve. But there turns out to be yet another trick. You start from here, let's call this X now, and let's call this Y. If you're computing from X to Y, you will be getting one elasticity. You'll be getting elasticity 1. And if you're computing from Y to X, in other words from Y to X, you will be getting a very different elasticity, okay? A lot of times for the elasticity, I omitted to mention is we sometimes use for demand elasticity will be always negative. Price goes up, quantity goes down, and vice versa. So usually the number is negative. And in economics we prefer to use positive numbers, so we take the modulus. So the minus or the plus actually in this particular case is irrelevant. In other words, whether you travel the path from here to here or here to here, the elasticity will be the same. We always use modulus, and it's a positive number. But the point is that if you travel from here to here, you will get one elasticity, one number, maybe 3. And if you travel backward, you will get a different number, maybe 2. Well, it could happen even that the unit elasticity is somewhere in between. And when you travel from the one to the other, you will get it to be inelastic. And when you travel the opposite way, you will get it to be elastic. So, we are getting to the other concept of a so-called base price. So, the base price is the price from which you begin to do the calculations. Why is the difference? Because the difference from, let's say, moving the price from 6 to 9 will give you a 50% increase, okay? But if you're moving from 9 to 6, the reduction is 33%, 1/3, right? 33%, 1/3. So, moving from 6 to 9 will give you 50%, moving from 9 to 6 will give you 33%. Well, with the quantities, of course, it will be the exact opposite, okay? So, it could very well mean, let's try with quantities. Quantity goes from 10 to 15. So, from 6 to 9, the quantity will be going from 15 to 10, right? When the price goes up from 16 to 9 will correspond. So this is price, this is quantity. What is the quantity change? 33%, right? Is that good? Now, if you're traveling from 9 to 6, quantity will be going up from 10 to 15. And this is a 50% change, right? So when you travel the path from 6 to 9, the elasticity is how much? What's the elasticity? When the first case, so we call this case 1, we call this case 2. We define elasticity as the 1% change divided by the other. On top we had the quantity, so 33% divided by 50%. The elasticity is how much? 0.66. So elasticity equals 0.66. Okay? In the second case, you have 50 divided by 33, and the elasticity is how much? 1 point, was it 66? Elasticity equals 1.66, okay? So, what I'm explaining so far is, you could move from 6 to 9, which means the price will, the quantity will drop from 15 to 10, and you will be getting 0.66 elasticity. But if you travel the other way around, you will be getting 1.66. So, in the one way, it is fairly inelastic. In the second case, it is fairly elastic. And this whole explanation makes the point that whether you begin from X to Y or from Y to X, it could make a world of difference. And the difference will be more significant and larger, the larger the difference between X and Y. Okay? So, the higher the difference. So, if you get to shrink the difference between X and Y, the difference between what we call here E prime and E double prime will be also shrinking. So, as you shrink the difference between X and Y, E prime and E double prime will be also shrinking. When you make the difference between X and Y, the distance between X and Y approach 0, meaning the 2 points are close to be practically 0. E prime and E double prime will also be approaching each other. In other words, E and E prime will begin to converge as X and Y converge. Alright? Have most of you done calculus? Derivatives? Okay, good. Alright, is this fairly intuitive explanation? Fairly clear? Alright, let's see what's next. So, base price. Okay, base price. And of course, to base price always corresponds the concept of base quantity. Simple as that. We call it arc elasticity, and we also call it point elasticity. This one has been covered. There's curvilinear demand, which I just want to skip. So, the point elasticity in the real world, we prefer to use the point elasticity typically when the change is small. When the change is small, you want to use point elasticity. If you're OPEC, you don't want to use point elasticity. Why?
Because the changes are not small.
Changes are not small. Price of oil doubled literally in 5 months. Then the price of oil collapsed in half in literally 3 months. So if you're doing oil, you'd better do arc elasticities. And you better also be very careful whether you move from $60 to $90 a barrel or from 90 to 60, or which direction is and what happens, okay? So this is important to understand what works with what. Alright, how much time do we have on the camera?
26.
26 minutes left. Alright, so let's move on to the next concept, and the next concept is that of income elasticity. So what will represent income elasticity? Let's see, delta change in quantity. So elasticity, income will be percentage change in quantity divided by percentage change in income. Okay? It's fairly straightforward. Turns out that if your income doubles, for example, income elasticity has a very nice interpretation. What's the interpretation? Income doubles, elasticity greater than 1. If elasticity is 2, this means that your consumption will quadruple. Right? Your income doubles, elasticity is 2, consumption will quadruple. Is that right?
2 by 2.
2 by 2, okay? 2 by 2. So, let's, apparently needs explanation, right? So, my income, somebody's income has gone from 1,000 to 2,000, alright? And they consume something, some good of, let's say, unit elasticity. They were buying 5 pieces, now they're buying 10 pieces. For this example, what is the elasticity of income? Elasticity of income is how much? How much? 1. Simple as 1. Now I'll do a cheap trick and I'm going to use the red. What if consumption didn't go to 10 but went up to 20? Right? Now I'm just using the red. So, income doubled but consumption went to 20. Then elasticity of income is 2. Alright? Fairly straightforward. Well, any memories of how we called those types of goods? More like luxury? More like luxury?
Yes.
So, luxury was when your income increases by a certain percentage. For a luxury, it will go up by a lot more. Alright? So, income doubles, consumption increases 4 times. It's a classic example of a luxury. Okay? What will be a normal good? What will be an elasticity for a normal good?
The same?
It's going to be more or less the same. Unit elasticity. For example, if it doubles with a unit elasticity, from 5 you increase to 10. So, it's more or less a normal good. Okay? Well, could income elasticity turn out to be negative? Is it possible?
No,
Is
you
it?
cannot lower it. If the income increases, you cannot lower it.
You cannot lower it?
Yeah.
Could it be?
Yeah. No,
Yes, it could be. Can you give her an example?
Inferior good.
Oh, inferior goods. So, let's summarize. Elasticity could be greater than 1, and then you get to the concept of a luxury. You can get elasticity which is now negative, and a negative elasticity will be interpreted as an inferior good. As your income goes up, the quantity consumed goes down, so a positive delta in income results in a negative delta in quantity, right? But this we just call inferior good. And you could actually have a normal good. So your income increases 10 times and my food consumption increases maybe 20%, right? So in this particular case, it is a little bit positive. So normal goods will have it between 0 and 1. All right? Let's try like this. From 5, it goes to 6. Okay? From 5, it goes to 6. Here, income, this is income, increases 100%. Here, quantity increases 20%, right? So we divide 20%, which is the quantity, by 100% the income, and we get an income elasticity of 1/5, right? Or 0.2. Is the good normal? I increased from 5 to 6 when my income went up from 1,000 to 2,000. Yes, it is perfectly normal. Actually, this is a very realistic example of income elasticity of food for fairly well-fed people. All right, those that aren't starving, those that aren't truly poor and underfed. So normally, if people's income increases doubles, usually they raise their expenditures on food maybe 10, maybe 20%. Of course, they can't just eat double simply because, you know, it's going to result in a waistline, right? Problems. So this is the connection between normal goods, luxuries, and inferior goods, and income elasticity. In the world of business, for you, it is important to understand for your particular good or service which you supply / manage as a manager, what is, number one, the demand elasticity, and second, the income elasticity. The income elasticity. Now, you also have a part of the income elasticity. This is the income with respect to the individual. With respect to the individual. Now, I don't think, and I don't remember seeing this in the textbook, but let's do it because it's important for investments in finance and also for managers running a business. So-called income, but income as it depends on GDP. As it depends on GDP. And usually that type of fluctuation in the income we call cyclical. Cyclical. In other words, as the business cycle moves rapidly on the way up, those goods which respond a lot, meaning are very sensitive, we call how? Huh? Alright, let's try the opposite question. As the boom is rising, the economy is heating, your demand changes very little. Now here's the trick. I'm tricking you here. The better way to think about it is, suppose the economy collapses in a major recession. On which things you're going to cut a lot and on which things you're going to cut little?
Luxury a lot.
Oh, luxury. So luxury goes a lot on the way up, right? Booming sales of BMWs. Of course, only 7 Series, right? Correct? Right? Yeah, well, sure. It's the same in Bulgaria. Well, until the credit crunch hit Bulgaria, same as over here, right? And on the way down, everyone cuts on the luxuries. So, for these luxuries, during the business cycle, we call these goods, and they have a name. We call them cyclical. Cyclical. So, cyclical goods are very sensitive to the business cycle. And that's why we call them cyclical. Those BMWs, you know, they fly off the dealer shelves during the boom, and during the recession, they stay. So the quantity of BMWs sold during the boom and during the recession could fall 10 times. Easily, 10 times. Of course, luxury homes will be another example. Quantity could easily fall 10 times. So those goods that are very sensitive to the business cycle are called cyclical. Now we have the opposite. Any examples of goods that no matter how bad the economy goes, you would not cut down a lot on consumption? Any examples?
Rice.
Rice. So some staple foods, okay? But people could cut if it is a major portion of their income, okay? So if it's 50, 60, 80%, and suddenly you have a recession, people can cut on that. So now we're looking into those goods where we not just don't cut a lot, but also represent a tiny percentage of our portfolios, or of our spending. Can you come up with a good that's...
Water.
Yes, water is a perfect... You're not just going to cut down on your water. On rice, some people actually do in relatively poorer country. Now, here is my best example that I can come up with. Brushing teeth, toothpaste, right? I mean, how much does it cost a month? Half a tube, one tube, $1, right? I mean, the economy can just go into, total collapse. You're still going to brush your teeth and still going to consume one, all right?
But you can change, I mean... like
You can change to a little bit cheaper, but I understand that one. You can change a little bit, but most people won't. Simply because
the
it
percentage
is a
of the value.
percentage of the total spending is, you were getting thousands, and now the average income fallen down to 500. Suppose, incomes collapsed in half. During a recession, the average for income falls about 10-20%, right? So, income fell 20%, 30%, you're not going to cut down on your toothpaste. Well, this is the idea, and we have a name in finance and in investments, and in general in economics. How do we call those goods which are not sensitive to the business cycle? Non-cyclical. Yes, that's a very nice way to say it, but in investments and in finance we have a well-established name. And if you say non-cyclical, people will wonder because they don't use it. Everyone calls it defensive. Defensive means no matter how bad the economy goes, demand for it will not fall a lot. All right? Now, give me some more example of defensive goods.
Medicine.
Yes, the perfect example. That's the bonus point. Yes, that's the best textbook example ever. People aren't going to cut on their medicine just because the economy went down a little or
But
a
if
lot.
they can't pay for it and it's really
That's a-
expensive.
It's a different story. Most of the people will continue taking their medicine. Let's try a different way. You got a bad headache, all right? And now, whenever you have it, whether it's recession or not, you're going to pay $2 to get the whatever you use.
High blood pressure medicine, you wouldn't stop it, you could die.
Oh, there you have it! You see what your classmate said? High blood pressure or insulin for sugar, right? Blood sugar. You're not going to stop just because you will die.
It's not like a flu medicine.
Yes, so even if it's a flu medicine you use once a year, 3 times a year. Flu medicine costs $3 or $10. The flu medicine represents a small percentage of your income. So it is still fairly defensive. So again, because you're going to die, well, somebody's going to die, not you. Meaning, because the sick person is going to die, the sick person can't just cut down on his medicine. So, healthcare and drugs, as in medicine, is typically very, very defensive. Food is typically very, very defensive. All right? So, let's see what else I have. Income elasticities, we did this stuff. Okay, marginal revenue, demand, and elasticity. Let's take a little pause here and a break.